We're using Sklearn's fclassif function, a statistical test that helps us pick the most important features in a classification problem. It uses an ANOVA f-test to assess the relationship between each feature and the class labels. Think of it as a tool to filter out noisy, irrelevant information. I have a dataset. It has 10 features, things we measure, like height or weight, and a binary class label, a simple yes, no or 0/1 outcome. I want to identify which features are the most influential in predicting this outcome. I apply the fclassif function to my dataset. This will give me two pieces of information for each feature, an f-statistic score and a p-value. The x represents my 10 features. Y is my binary class label, it's what I'm trying to predict. These numbers measure the variance explained by each feature relative to the variance within each class. A higher score suggests that the feature is a better predictor. Alpha, my significance level, is set to 0.05 or 5%. It's a threshold I use to decide if a result is statistically significant. If my p-value is below 0.05, I consider the result significant. It means the chances of observing my results by pure luck are less than 5%. I'll select only those features where the p-value is less than my significance level, 0.05. This indicates a low probability that the observed relationship between the feature and the class label is due to random chance. Based on my analysis, features 0, 3, 5, 7, 8, and 9 are the significant ones. Their p-values are below 0.05. This statement correctly describes my selection criterion. I select features based on their p-values being less than 0.05. It's the key to my feature selection process. This statement is partially correct. It includes some of the selected features, but not all of them. It misses features 8 and 9. Again, this is partially correct. It correctly selects features with p-values under 0.02, but it ignores some significant features with p-values between 0.02 and 0.05. I'm working with a dataset. It has 10 features, which we can think of as different characteristics or measurements. And it also has a binary class label. This means each data point belongs to one of two groups, like yes, or no, or cat, or dog. We'll use this dataset to select the most important features. I'm using the _f_classif function from the Sklearn library. This is a statistical tool that helps me figure out which of my 10 features are most important for predicting the class label. It does this by calculating an f-statistic and a p-value for each feature. I've set my significance level, often called alpha, to 0.05. This is a common threshold in statistics. It means I'm willing to accept a 5% chance of mistakenly saying a feature is important when it's actually not. This is kind of like setting a bar for how certain I need to be to declare a feature important. The f-statistic scores tell me how much each feature explains the variation in the class labels. Higher scores suggest a stronger relationship between the feature and the class. For example, feature 3 has a very high f-statistic of 25.1. Suggesting its very strong influence in distinguishing the class labels. I have a dataset with 10 features, represented by X, and a binary class label, represented by Y. The X represents the various measurements that characterize each data point and Y is the label indicating what category it belongs to. These are the features I've selected because their p-values were below 0.05. This means that based on my analysis, these features are likely to be important to separate my data into different classes. I'm using these values to make predictions about my binary class label. I have a dataset with 10 features and a binary class label. Think of it like this. I'm trying to predict whether something is a cat, 0, or a dog, 1, based on 10 different measurements, features, of the animal. I use this function from the Sklearn library to select the most important features for my classification task. It uses a statistical test, ANOVA f-test, to determine which features are most strongly associated with the class labels. Basically, it helps me decide which of my 10 measurements are actually useful for telling cats and dogs apart. This is my threshold for significance. I set it at 0.05, meaning I'm willing to accept a 5% chance of mistakenly identifying an unimportant feature as important. It's a common standard in statistics. These numbers represent the strength of the association between each feature and the class labels. Higher scores suggest stronger associations. For example, a score of 25.1 indicates that feature number 3, the fourth element in the list, is much more strongly associated with whether the animal is a cat or a dog compared to a feature with a score of 0.8. I am being asked to interpret the results of the feature selection and select the correct answers about which features are considered important based on the p-values. I need to determine which features are important for prediction based on a significance level of 0.05. This means I'll only select the features that have a very low probability of being irrelevant to the class labels, cat or dog. This statement says that I should select any feature whose p-value is less than 0.05. That's the correct way to make my decision based on my significance level. This gives a partial answer. It identifies some features, but not all of the features that meet the criteria described in option B. This statement is partially correct. It correctly selects a subset of the important features, but it doesn't include all features that should be selected based on the p-value threshold of 0.05. My data has 10 features, X, which are my measurements, and a binary class label, Y, either 0 or 1, which represents cat or dog. Here are the results of the f_classif function. The f-statistic scores show the strength of association for each feature, but the p-values are what I really care about. For feature selection, because they tell me the probability of observing these results if the features are actually unrelated to the labels. Based on the p-values and my significance level, 0.05, features 0, 3, 5, 7, 8, and 9 are selected because their p-values are below 0.05. I'm using the fclassif function from Sklearn, a popular machine learning library, to pick the best features for a classification task. This function helps me determine which features are most important for predicting my class labels. It's like choosing the most informative ingredients for a delicious recipe. I have a dataset with 10 different features, X, which are characteristics or variables, and a single binary class label, Y. Think of features as different qualities of a product and class label as whether you would buy it or not. A binary class label means the label can be only one of two things. For example, yes, or no, 0, or 1. My goal is to predict this label using the features. The fclassif function calculates an f-statistic and a p-value for each feature. The f-statistic measures how much each feature helps us discriminate between classes. The p-value tells me the probability of seeing that f-statistic if the feature were actually irrelevant. In simple words, it helps to determine which features are really important for classification. I get a score for each feature indicating how well it separates the classes in my dataset. Higher scores mean a feature is better at distinguishing between classes. For example, a score of 25.1 is much better than a score of 0.8. These are the probabilities of observing those f-statistics by chance if the features are actually not related to the class labels. Lower p-values indicate that a feature is more likely to be truly relevant. For example, a p-value of 0.001 is much more significant than 0.78. I set a significance level, often called alpha, to 0.05. This means I'm willing to accept a 5% chance of incorrectly saying a feature is important when it isn't, a false positive. I only select features whose p-values are less than 0.05. This means there is less than a 5% chance I'm wrong about that feature being important for classification. Based on my criteria, these are the features I've selected because their p-values are below 0.05, meaning they are statistically significant in my classification task. We're using a technique called f_classif from the Sklearn library to pick the most important features from our dataset. Think of it like choosing the best ingredients for a recipe. We want to only keep the ones that really matter for a good outcome. Our dataset contains information about 10 different things, features, and each data point has a label saying whether it belongs to one group or another, binary classification. Imagine it like having 10 measurements for each person, and you're trying to group the people into two categories. I have 10 different features, X, that describe the data. Y is a simple yes, no label that tells us which group each data point is part of, which is our target. Think of X as a set of ingredients and Y as the final dish. We are trying to figure out which ingredients are the most important for our dish. This is a function within the scikit-learn library that helps us select the features that have the strongest impact on our classification goal. It uses statistical tests to measure the importance of each feature. The f_classif function gives us two things for each of our 10 features. An f-statistic score, how much the feature affects our classification, and a p-value, a probability. A low p-value means the feature is likely important. This is our threshold. If the probability that a feature is unimportant, the p-value, is less than 0.05, I consider the feature important enough to keep. It's like setting a bar for how sure we need to be before we keep something. Based on this significance level, which features should I keep? This is the core question. Let's decide which features make the cut based on their p-values. Let's do this. This is wrong. The f-statistic gives us some indication, but the p-value is the one that tells us definitively if it is significant. This is mostly right. It correctly states how we'll choose the features but doesn't list the exact features. This is partially correct. Only a few of the features which have p-values below 0.05 are mentioned. Again, partially correct, it misses some features that meet our criteria. We're using a technique called fclassif from the skikitlearn library to pick the most important features from our dataset. It helps us decide which features are most useful in predicting the class label. I'm working with a dataset containing information about various things. This dataset has 10 different features and a binary class label. A binary class label simply means it's either one thing or the other, like yes, or no, or 0 or 1. These are the 10 different pieces of information I have about each item in my dataset. Think of them as different characteristics or measurements. This is what I'm trying to predict based on those 10 features. It's a simple yes, no or 0 over 1 answer. This is the statistical test I use to figure out which of my 10 features are most helpful in predicting the class label. It calculates f-statistics and p-values for each feature. After running the fclassif test, I get two numbers for each feature, an f-statistic and a p-value. The f-statistic tells me how much each feature helps me predict the outcome, and the p-value tells me how statistically significant this relationship is. This is the threshold I set. I'll only consider a feature as truly important if its p-value is below 0.05. It's a common standard in statistics. These are the features that pass my 0.05 p-value threshold. They're considered statistically significant in predicting the class label. Time to put my knowledge to the test. I need to figure out which features are selected based on the p-values and the significance level. This option looks only at the f-statistic score, ignoring the significance level, p-value. I need to use the p-value instead. This option is the correct criterion for feature selection. Features with p-values less than 0.05 are considered statistically significant. This option lists some, but not all, of the features with p-values below 0.05. It's partially correct. This option is too restrictive. I'm only interested in features with p-values less than 0.05, not just less than 0.02. I'm using scikit-learn's fclassif function to pick the best features for a classification problem. This function helps me choose the most important features from a dataset. I have a dataset with 10 features, X, and one binary outcome, Y. The Y tells me what class the data belongs to. It's like having 10 pieces of information about something, and Y tells me whether it's a cat or a dog. This is a statistical test from scikit-learn. It helps me see which features are most useful for predicting the class label, Y. These numbers show how strongly each feature relates to the class label. Higher scores suggest a stronger relationship. Imagine it like a competition, where a higher score means the feature is a better predictor. The scores are 10.2, 1.5, 0.8, 25.1, 3.7, 18.9, 0.2, 12.7, 6.1, 9.3. These values tell me if a feature's relationship with the outcome is statistically significant. A small p-value, below a certain threshold, called alpha, means that the relationship is likely not due to random chance. My p-values are 0.001, 0.21, 0.45, 0.0001, 0.05, 0.0002, 0.78, 0.0005, 0.02, 0.002. Alpha is my threshold. If a p-value is less than 0.05, I consider the result statistically significant, meaning, the link between feature and class isn't just random chance. It's like setting a bar for how confident I want to be before claiming that a feature really matters. I selected the features with p-values below 0.05 features 0, 3, 5, 7, 8, and 9. These features show a statistically significant relationship with the class label, Y. These are the feature indices I selected based on a significance level of 0.05. They passed the test, and are important for my classification model. Fantastic.